Okay, as I already described these different scenarios of exciting different modes of vibration of the system, I'm pretty sure that you all know how we can actually excite the bounce mode only, or how we can excite the bounce and roll modes simultaneously. So in this video, I'm going to just show you how we excite bounce mode and then bounce and roll mode together. So for bounce mode, for excitation of bounce mode, I just bring down the crane and then let's just bring it down. Okay, and then I lift it up a little bit, meaning that I change the its initial actually I introduce a kind of initial deflection, and I keep the symmetrical actually shape of the structure, symmetrical arrangement of the structure to avoid any roll mode excitation. So let's see how it goes. So I'll just release the crane. So this is bounce mode only.
Okay, what you can see here is the raw time data for bounce mode only. So basically you can clearly see here that we've got offset, and so the point is that we cannot simply AC couple to remove this offset, because the AC coupling is a kind of high pass filter, and so for these low frequency signals, such a filter would also attenuate the vibration frequencies of interest. And so we need to remove the non-zero offset by some means, by some actually some calculations from for both left-hand side and right-hand side displacement signals. Okay, why do we actually need to remove the offset? The answer is that, you know, in vibration and in dynamics, we are talking about dynamic systems, and so the offset here represents the static deflection or the static displacement. So basically we don't need to have those displacement, those static or basically DC offsets. And so we can simply and readily get rid of those offsets by subtracting the raw time signals from the mean of the signals for example here, for the signals between 4 to 4.5 seconds or between 4 to 5 seconds. As I previously emphasized, we need to think carefully about the independent and dependent coordinate system, and about independent and dependent measured signals. So, and if there is any dependent and independent coordinates, we need to define the relationships between them so that they can convert measured data into independent coordinates at each moment in time. So basically what you can see here is that we have already converted the x left and x right into xcg and theta, basically into the displacement of center of gravity and into the rotation of the spring mass.
Okay, now I'm going to excite bounce and roll mode together. So to do that, I'll have already brought the crane to this side, and then I'm going to just, I have already lifted up the crane, so I'm going to just release it and you see how it goes. Yes, you see that it's just actually vibrating this way, and at the same time it's vibrating this way. So we've got bounce mode and roll mode simultaneously.
For the case of bounce and roll mode excitation, you can clearly see that the amplitude of the rotational vibration theta is considerable and is pretty much larger than the amplitude of theta for the case of bounce mode only.